morning, everybody. Thank you for being here at 8:30 on a Friday morning. We're going to get started with the student session, and I just want to make a quick announcement that there is a discrepancy between what's on the board outside and what is in the agenda that's printed online as well as the app. So what we're going to do is we're going to stick with the schedule that's from the app as well as that in the agenda. So the order of our speakers is going to be first William Clark, then Lauren Anderson, then Christiana Aid, then Michael Letzering. All right, so we're going to start our presentations. Each of them will have about 20 minutes with about 2 to 3 minutes for questions because we're on a tight schedule with only 4 students speaking here today. And we'll get started with William Clark. He is at UNC Asheville pursuing his BS in meteorology, and today he'll be giving a talk entitled The Automated GIS for Climate and Weather Resilience.
Yep, so I am at UNC Asheville, and I'm also an intern at the National Environmental Modeling and Analysis Center. So a quick outline, the motivation of this research, the model structure and the flow of the software, the data that is used within the model, the results of it, use cases that are currently happening now, and the end user, which is really important for government, as well as conclusion and future work. So during Obama's administration, he passed 2 executive orders to prepare the United States for the impacts of climate change, as well as floodplain management. And this kind of stemmed the U.S. Climate Resilience Toolkit. And also every 4 years, the 3rd National Climate Assessment is published through the White House. So within the 3rd National Climate Assessment, I was once a researcher for that, and in the back of it, in the research needs section, there was to expand climate impacts and analyses to focus on understudied but significant economic sectors, as well as to create tools to study these sectors. And so what other perfect tool to study these sectors but GIS? So my model foundations are based off of a Python PostgreSQL database, and it makes it more robust, flexible, and easy to use using vector and RASP data. So and then the outputs are spatial analytics. So this is the algorithm for that. So there's a spatial intersection and selection. I then classify the risks given the damage values, and then summary statistics of the appraisal values or what have you, maybe length of roads, and then locational analysis of which parcels or which roads are affected. So this is what the software stack looks like. Postgres, pgadmin, PostGIS, GDAL, and Python, and then map server and open layers to visualize it. So what's so cool about this is that it's all universal and dynamic. So any hazard or asset can be assessed. And it can also be updated at any time. So if, say, your parcel data updates, then so can your model. So then your results change, and it's very fluid. And then the locational intelligence behind GIS allows for you to do resiliency planning on the local level, or county, or maybe even state, national level. So the model data that goes into this is bridges, greenways, roads, networks, road networks, parcels, buildings, and the climate data, and all that's accessible, the asset data, through your local municipalities or through a federal organization. And then the climate threats are wildfire probabilities, which is given to me through NCDEQ, 100 and 500 year floods, landslides and debris flows, and the sea level rise. And then weather. So recently, the National Hurricane Center produced an experimental product to forecast storm surge real time during an incoming hurricane. And then a hurricane surface winds model that I derived using dynamics. And then these are 2 pictures here after Hurricane Matthew, and in 2004 after Hurricane Rita in Asheville. So this is the raster for wildfire probability overlaid on Buncombe County. kind of focused in on the city of Asheville, and it's just ingested, kind of on the fly using GDAL to import that. Parcels exposed to 100 and 500 year floods, and landslides and debris flow pathways. So these are just three threats applied to one asset, and it can be a multitude of threats and assets. So this is storm surge for 5 counties in eastern Florida. And this model was actually created these results were created while Hurricane Matthew was about to hit. And this is the parametric wind profile from Hurricane Matthew as it was coming onto shore. And so this is an example of the loss statistics generated from the surface wind profile and the storm surge profile. And so there was a 5% chance of $68 billion worth of loss and a 95% chance of $3 billion worth of loss. So overall, though, this model is currently being used in the city of Asheville for resiliency planning and policy creation, as well as the Triangle J. So using the steps of resilience within the U.S. Climate Resilience Toolkit. And so who else is the end user? Well, the finance industry, catastrophe bonds, which are insurance-linked securities. So if you know a hurricane's coming and you know there's bonds being taken out on a piece of property, well, you can bet against that. And then reinsurance, that's more of climate, hurricane tracks, surface analysis, and then real estate industry. Utilities, hurricane's coming, it knocks out a bunch of power lines, and those power lines are down for, say, a day or two. When they're down, that's wasted energy. And so when you have wasted energy, wasted load, you lose money. And then federal, state, and local governments for resiliency planning. And then, of course, individual homeowners like this gentleman here. So in conclusion, an automated real-time analysis of loss was created. It's currently being used for resiliency planning. It's most likely applicable to cat bonds and commodities trading in real time. And it can also be used for other things in finance like reinsurance. So some future work. I'm running this on a very small Amazon instance. And so I need more data processing, more power. If I had more power, I could do better analyses, maybe even bring in precipitation from radar data. And then hopefully I'm able to create 5-day graphical outputs of loss via forecasted winds, forecasted storm surge. A BIM, a building infrastructure model, would be really useful for the insurance industries. Then, of course, I guess, well, not I guess, but the only thing that's more important than money is people. So, impacted population. So, and this is, of course, Hurricane Matthew in Asheville, North Carolina. And yeah, that's it. Any questions?